All right, let me start off by introducing myself. Hello, my name is Lance Zurich, and I'm the product manager for the Fischertechnik division over here at Studica. And today I'm going to provide you with an overview of the Fischertechnik Education Robotics Competition Set. Now, this set is designed to provide students with the tools and the background needed for participating in robotic competitions. And this would be whether we're talking about something at the local level or even large-scale national and international competitions, things like the RoboCup Junior, for example. But more than that, the set was also designed to enable educators to provide students with a project-based, standards-focused curriculum program which involves inquiry, design, and problem solving. Now, the curriculum for this set, like the curriculum for Fischertechnik's other curriculum-focused project-based sets, things like the STEM engineering set, which is the focus of its own presentation, the curriculum for this set was created especially for Fischertechnik and Studica by noted educator and STEM expert Tom White. So just to get things started, we will address the question that always comes up, which is, what is STEM education? Well, of course, most educators probably are aware that the term STEM is an acronym, the letters of which stand for science, technology, engineering, and mathematics. And of course, if you're involved in any aspect of education, you probably can't open your email box without seeing STEM highlighted in the subject line of at least one of your daily messages. And you really can't read an educational journal, or when you're able to visit an educational conference, you can't really go without being bombarded by references to STEM. And the reason for this is really pretty simple. To quote the bipartisan Congressional STEM Education Caucus in their report on the importance of STEM education, they said, quote, that STEM education is necessary because it helps provide the scientists and engineers needed for future development, provides the future workforce with the skills required of a high-tech world, and it builds the foundation for scientifically literate voters and citizens. Now, with this in mind, STEM education can really be considered kind of a matter of national security. On every level, the world around us is changing at a frantic pace. STEM education, it could be argued, enables us both as individuals and as a nation to understand and keep up with these rapid changes in technology, changes which in turn are altering the demands and the scope of industry. And obviously, if we as a nation are to keep our stature and position on the world stage, this requires us to keep pace with the rapid developments that are occurring all around the globe, where countries such as China and India are making major investments in state-of-the-art infrastructure. And while all of that's well and good, and we should, of course, all strive to be good citizens, many students might also ask, so what's in it for me? Why do I want to study engineering, or why do I want to study coding, or what have you? So let's consider what it means on the individual level. Well, first off, a few years back, the United States Department of Commerce released a set of projections for the decade leading up to 2018. And these projections indicated that STEM occupations would grow by 17%, compared with 9.8% growth for all other occupations. Now, in March of 2017, the Office of the Chief Economist released a STEM Jobs 2017 update, which basically took a look at how these numbers were playing out up until the end of the year 2015. And at this point, this was with 3 years still left in the initial projection. Now, what they found at that point was that while the projected STEM growth, again, up till the end of 2015, was a bit less than they were expecting to reach by the end of 2018, in this case, what they had shown was they showed 14% growth out of the 17% that they were actually expecting to reach. By comparison, the actual growth for non-STEM jobs, which again was expected to reach as high as 9.8%, instead only reached a fraction of that, 1.7%, which is a pretty stark difference. Now, here's a statistic that I like to share that should give anyone entering the job market of the future pause, and this comes from J.D. Chesloff in his Education Week article from March of 2013. To quote Mr. Chesloff, across the country, across all occupations, there are 3.6 people for every one job. In STEM fields, there is 1 person for every 1.9 jobs. Employers can't find the talent to fill these jobs, which is even more surprising considering the US Census Bureau recently reported that the median salary for engineering majors was the highest of any profession, end quote. Now, as Chesloff goes on in the article to state, quote, supply is low and demand is high. There is a mismatch between projected future jobs requiring STEM skills and the projected supply of qualified workers to fill them, end quote. Going back to the STEM Jobs 2017 update released by the U.S. Department of Commerce, which I referenced a few slides ago, here are 3 key points mentioned in this report that are well worth keeping in mind when considering the importance of STEM education to the worker. Key point 1, STEM workers command higher wages, earning on average 29% more than their non-STEM counterparts in 2015. Key point 2 relates to the fact that many graduates with STEM skills may not always end up in what are strictly considered to be classic STEM related jobs. And these would be things that we would think of like becoming a scientist or an engineer or something of this nature. To quote the report, STEM degree holders enjoy higher earnings, regardless of whether they work in STEM or non-STEM occupations. End quote. So what does that mean? Well, there was a video I saw recently on YouTube posted by the Women's Forum for the Economy and Society. And the title of that video I thought really summed up things nicely. And the title was, quote, "Every company is a tech company." So essentially, what I took from that and what I think students want to keep in mind is that whatever a company makes, whatever a company sells, or whatever service it performs, at some point along the way, STEM skills are required to help that company fulfill their mission. Now, moving right along to key point number 3, this relates to job growth. Quote, "Employment in STEM occupations grew much faster than employment in non-STEM occupations over the last decade." This was 24.4% versus 4% growth respectively. And STEM occupations are projected to continue to grow by 8.9% from 2014 to 2024, compared to just 6.4% growth for non-STEM occupations, end quote. With all of this in mind, the trick for educators is, of course, finding methods for getting students involved with STEM, and in particular, getting them involved with those most highly in demand technology-focused skill areas, which again are things like engineering and coding, and to do so in a way that engages the students' interests and creativity, while at the same time developing the work habits, the way of approaching problems, and the skill set they're going to need drawn as they move forward in their careers, both academic and in their working lives. Now, most experts agree that one of the most effective methods for teaching STEM is by providing exercises where certain results will occur and the students have to discover why those results occurred, or in cases where students have to find a way to achieve a specific outcome. So how do they do this? They'll do this through experimentation, through research, and through trial and error activities. In short, they find the answers to these questions through the use of hands-on project-based learning. And that brings us to the focus of the webinar, which is, of course, the Fischertechnik robotics competition set. Now, this set was designed to be essentially it's designed to provide a guided project-based learning experience complete with detailed curriculum, all of which uses the unique Fischertechnik building system. So that brings up a question, what is Fischertechnik? Well, just to provide you with a little bit of background, Fischertechnik is a flexible and innovative construction system. Now, unlike other popular construction sets that are designed to simply stack, Fischertechnik was created with more of an engineering mindset. The core building block in the Fischertechnik system is unique in that it allows attachment from all 6 sides, and because of this, it allows for almost limitless design possibilities. Now, many of the parts are designed to slide together and lock in place, and the hundreds of different parts available will also help to address very specific design needs. Fischertechnik was created back in 1964 by German inventor Arthur Fischer, who's noted for countless innovations used in the construction and the automotive industries. In fact, Mr. Fischer, at the time of his death in 2016, held more patents in his name than Thomas Alva Edison had amassed during his own lifetime. Now, besides Fischertechnik, Mr. Fischer was the inventor of synchronized flash photography, and this was back in 1949. And he was also the creator of the expanding nylon wall plug, which is used in conjunction with a screw or a bolt, for example, to help anchor heavy objects to walls. His company, the Fischer Group, employs thousands of workers worldwide involved in producing many variations of fastening devices used in building construction, as well as various components used in the automotive industry. And they also provide consulting services in regards to various high-end manufacturing processes. Now, I'd also like to mention that Fischertechnik was the very first construction set to offer students the ability to build and program their own robots, and this was using the original pre-Macintosh era Apple computers. Now, almost since its inception, Fischertechnik has been used by middle schools, high schools, colleges, and universities all around the globe to explore STEM-related subjects. And these are, of course, things like robotics, renewable energy, pneumatics, mechanics, optics, and many, many more. Now, Fischertechnik has also been used by numerous companies, including companies like Porsche, Daimler Chrysler, and BMW, just to name a few, for industrial simulation and training purposes. In addition to this, over the last several years, Fischertechnik's line of pre-assembled simulation models have found wide adoption for demonstrating and exploring the world of IoT, which is, of course, the Internet of Things. And this is where industrial processes can be monitored and controlled from a cloud. Now, as such, more than just being something that students may use for only a year or two in their development, Fischertechnik is designed so that students can grow along with it. Now, as students progress through their academic careers, they can also progress through the levels of Fischertechnik education solutions which are available. The Fischertechnik Robotics competition set is designed to provide educators with a clear and detailed pathway for exploring the subjects of robotics and coding through the focus on learning on how to create mobile robotic models for use in a competition setting. The set itself is designed for use by teams of 2 to up to 4 students at a time. The set contains 670 components, all of which come packaged in a sturdy plastic Ratinel storage box, just like you see on the screen right now. The set is designed to provide all the materials that you will need, and by this we mean both the physical and the instructional materials, to enable teachers to offer a complete, standards-aligned, curriculum-based competition-focused class or after-school activity. The curriculum used with the robotics competition set was created especially for Fischertechnik by a man named Tom White. Now, Tom is a noted educator who's been involved in STEM education since the 1970s, and he's known for designing programs for educational institutions and for industry use. In fact, as an expert in hardware and software integration, Tom was pivotal in introducing CAD, CAM, control systems, digital control, additive manufacturing, and other such topics to the classroom. Now, currently, Tom is the Director of Technology for STEM curriculum at the globally recognized industrial manufacturing company, Siemens. Now, this isn't the first time that Tom's created curriculum using Fischertechnik. He's created, again, as I mentioned, the curriculum for other project-based sets we have, including the STEM engineering set. And he's also created curriculum for a pair of sets that we use for introducing STEM in elementary levels, Introduction to STEM 1 and Introduction to STEM 2. But besides this, Tom has also incorporated Fischertechnik in many of the educational programs that he's designed over the years for schools and for other institutions. And Tom has often said that he believes Fischertechnik is the ideal construction set for any kind of engineering-based curriculum program. He's given several reasons for that. First, he really likes that the materials can be used and reused. Things that are built can be taken apart and reassembled into something completely different, so everything is reusable. He also likes the versatility of Fischertechnik and the fact that it offers so much more economy than purchasing an expensive piece of equipment, for example, something like a robotic arm, where it might only be used for a few experiments and then it goes to sit on a shelf until the next year. He also appreciates that the Fischertechnik system, with its wide assortment of very specific mechanical and structural parts and components, allows users to almost limitless creative opportunities and almost limitless creative license for designing any kind of engineering project that they want to build. Now, when Tom designed the curriculum for these project-based learning sets like the robotic competition set, he had several goals in mind. First, based upon his observation that various types of teachers have different strong points. For example, he'll often say that he sees his own strong point being more in the end of creating curriculum such as this, more so than, let's say, conducting a lecture. But with this in mind, he focused on creating detailed curriculum that would provide a broad foundation of tools for all types of teachers to be successful in providing this class so that they could instead focus on the needs of the students. And he also made sure to include a special tutorial section at the beginning to familiarize new users with how the unique Fischertechnik building system works. And he made sure that each section of the curriculum clearly spells out how everything will be addressed in that specific unit. In short, He designed the curriculum and selected the components included in each set to essentially act as a turnkey solution that would provide everything teachers should need to deliver the material effectively and all in one place. Now, again, the curriculum was designed to provide a clear roadmap for both the students and for the teachers. The goal was also to enable teachers to provide students with engaging curriculum-based projects that had an authentic objective in solving real-world problems and which contain embedded academics. The detailed curriculum with this set, if followed, provides the basis for what could be a standalone project-based robotic class, or again, an ongoing after-school activity. Under this project-focused model, students are told upfront what they will need to learn and understand. They're given a real-world scenario where they take on the role of a professional working on a team, which has been presented with a design challenge that they must devise a solution to, and they are then provided with different tools and pathways to help them achieve this goal. Now, among other things, students must perform research, and this is research both inside and outside of class. And they also learn the documentation process, and this includes things like creating a design brief or maintaining a digital engineering journal. And they're also going to collect data. They're going to learn firsthand how data acquisition works. They're going to learn how to process data, how to put data into graphs and other formats, and so on. Students are given a technical literacy task that is driven by the project. Fulfilling this task will require them to gain the knowledge and the tools needed to address it through research and exploration. Students will perform a series of specially designed enabling activities through which they will acquire the necessary science, math, and tech-based skills. They're going to devise solutions to their tasks and create prototypes, again, using the advanced Fischertechnik modeling system. Students will then create and install the programs needed to control these prototypes. Again, they're going to document every step of the entire project. And at the conclusion of each project unit, each group of students will be required to formally present their findings, including a demonstration of the prototype and/or the programming in action. The curriculum itself comes in the form of a 576-page downloadable PDF document. This document, which we will explore shortly, contains detailed academic material for use in a classroom or an after-school setting, as well as full-color step-by-step assembly instructions for building a series of 20 different models. These assembly instructions are included both as part of the PDF documentation and also in a printed physical form in each set. Now, as many educators and students might be new to the Fischertechnik building system, once again, the curriculum PDF also includes a helpful tutorial section at the beginning to help both students and teachers quickly get up to speed with using this system. Now, this section covers such areas as how to identify the various parts being used, learning how those parts fit, learning how those parts fit together, and even assembling a basic model. The curriculum is divided into 4 main project themes. The project themes or units focus on competitions, programming, sensing and vision systems, and mobile robotics. Now, the curriculum as a whole is designed to provide enough academic material to cover approximately 70 hours. Now, according to program creator Tom White, there is room here for educators to be flexible with this if they'd like. Now, as he pointed out to me recently, a teacher could, for example, leave certain things out and use this to fill approximately half a semester, assuming a daily class period of 50 minutes a day, 5 days a week dedicated to the subject. Or if they wish, they could add some hours of experimentation, easily bring it up to 90 hours or so, once again, depending on what works best for the teacher and how you wish to present the program and the material. During the course of the 4 project themes, various activities are also addressed and various subjects are touched upon. And this includes things like sketching, schematics, Ohm's law and power, an introduction to using the RoboPro software, which is the control software used with these parts, an introduction to using the TXT controller, working with flowcharts, working with open loop and closed loop programming, and digital branching, edge triggered versus level triggered, logic gates, combinational logic, analog branching, variables, data, Sensors such as the digital switch and the digital phototransistor and the digital trail follower, analog sensors including the NTC resistor, the Photocell LDR, the color sensor, and the ultrasonic distance sensor. An introduction to using the camera attachment, using this camera to detect motion, working with color detection, creating a ball finder, which involves using the camera on a swiveling base, working with the line tool and the encoder motors, and building the control panel. Now, I'd also like to point out that the curriculum for the Fischertechnik robotics competition set has also been designed to address some of the most widely recognized academic standards that are currently in place in the United States. This will include things like the college and career readiness standards for math, science, reading, and writing, the NSES content standards for technological literacy, the ISTE Foundation standards, and the next generation science standards. Now at this point, let's look very briefly at some of the actual physical materials included in the robotics competition set. Now, as I mentioned previously, each set contains 670 parts and components, and this includes a license of the RoboPro graphic programming software, which is designed for Windows-based systems. It also includes the powerful and compact Robotics TXT controller, which has a full-color touchscreen, Bluetooth and Wi-Fi connectivity. It has programmable sounds and many, many other features, and also a Fischertechnik rechargeable battery pack and charging unit, which is used for powering all of the mobile robotic models. Now, among the specialized components included in each set is a gyro sensor, which is only available in this particular set. There are 2 encoder motors. There's the USB camera attachment for building robots with vision system capabilities, which we touched on before. There's a phototransistor, an XS motor, 2 push-button switches, a color sensor, an NTC resistor. There are 2 LEDs, 3 ultrasonics distance sensors. There's an IR trail sensor, a photoresistor, a reed contact, and of course, there are hundreds of other parts of various types, all of which compact in a sturdy gratinal storage box. Now, the set also includes printed materials such as the full-color 74-page pictorial assembly manual with instructions for building 7 different stationary and 13 mobile robotic models, for a total of 20 models in all. Also included is a printed sample track and a side fence. Now, essentially, even if one chose to ignore the standards-based curriculum, you could still view this as the ultimate Fischertechnik mobile robotics set. Now, the contents of this one box will allow you to build all of the models found in both the Fischertechnik Robotics TXT Advanced set and the Robotics TXT Explorer set. Again, everything students are going to need to build all 20 robotic models is included here. And again, that includes the programming software, the controller, the power supply, and of course, all of the various parts needed. Now, as I mentioned a few times, that this set will allow you to build 20 different robotic models, which are basically, this is in addition to what you're going to be doing in the curriculum itself. Let's take a very quick look at these models. Now, again, please note that these are, of course, not the only models you're going to build with this set. In fact, each of the 4 project themes explored in the curriculum will really only use these models we're about to look at as is best a reference point. And instead, what's going to be required of the students is that in each of these project phases, they're going to need to design and build their own original models to help solve the core problem being put forth in that unit. So with this all being said, this one set will still include all of the parts required, as well as the detailed step-by-step instructions for building each of these models we're about to look at. And these can be used basically to be studied and experimented with on their own, or to used in ways to help students explore and understand the concepts that they're going to draw upon for their own unique projects. So they can basically take different things that they learn from how these models are constructed in building the projects they're going to be working on. So if we take a look, you'll see things like the automated ventilating fan, a temperature control robot, an automated hand dryer, a traffic light simulation, an automated parking barrier, a swiveling security camera with alarm, a cameraman, and then we get into the basic, we get into the mobile robots, starting with a basic mobile robot, a hindrance detector with a camera attachment, a trail searcher, a detection robot, a soccer playing robot with movement control. Then you have a soccer robot where the movement control or the camera is mounted right on the robot itself. You have a basic tracked model. You have a trail searcher, a tunnel robot, a color detector, an explorer robot, a rescue robot. Now, let us turn our attention to the curriculum itself. Now, at this point, as we've already established the themes and the concepts of robotic competition set will help you address in the classroom, let's now take a look at how the curriculum itself is structured. Each of the 4 project themes focused on the curriculum for the robotics competition set contains a roadmap of sorts where each of the following elements will be addressed: the purpose, the concepts, the student deliverables, assessment and evaluation materials, an outline, the standards, an authentic project scenario, a daily teaching plan, supporting activities, and resources. Now, here is the table of contents for the robotics competition set. The first thing I'd like to point out is the section right at the beginning that as I mentioned previously, it's designed to help new users of the Fischertechnik system to quickly get up to speed. Now, again, the core building blocks used in the Fischertechnik system are designed to attach from all 6 sides, and many of the other parts are designed for very specific design purposes. Now, as of course, this is going to be a little bit different than the simple stacking construction of many other building sets that students may have worked with. Because of this, we've included this section right up front to increase both your comfort as a teacher with using this and also the comfort of the students using the system to allow both you and your students to get the most out of your building experience overall. So it's going to include sections such as showing how various parts fit together and discussing the pin and groove assembly methods used throughout. You're going to have a section showing you how to identify the different parts from core building blocks to more specialized parts, things like the different types of clip axles, girders, different types of rivets, angle pieces, and much more. And also for those educators who are new to conducting a class of this type, because it is a different type of class to be conducting, there is a chapter specifically discussing project-based STEM education. Now, after all of this comes the introductory section where we have the 4 theme units, which I introduced earlier in the presentation. Again, these are competitions, programming, sensing and vision systems, and mobile robotics. Now, in the following slides, I'm going to show some examples from each of these 4 units. I'm going to jump around a little bit and show you how they address the structural format as I touched upon a few slides ago. Now, each theme unit will start off with a section outlining the purpose of the project that's going to be addressed in that particular unit. And this is the section that really spells out for students a clear answer to that internal question, why are we doing this? And it also talks about the skills that we hope to develop here. Now, in this example shown here right now on the screen from the unit on programming, the focus is going to be on students designing and implementing a program to control an automated system. Now, next in the progression, this is followed by a section listing the concepts that are going to be addressed in that particular unit. And these can be thought of as the big ideas that students should learn from this unit and that are going to be useful and vital for them to understand and know, not just in completing the projects they're going to be doing, but also to draw upon as they move forward in STEM fields of study. And we would all, of course, hope in STEM-related careers someday. Now, this particular section, which you see on your screen right now, it happens to be taken from the unit on competition. And it provides an overview on some of the areas students will begin to learn about and explore here. And this includes things such as control statements, linkages, mechanisms, automated systems, sketching, and much more. Next up is the outline, and this is found in 3 of the 4 project theme units. Now, in this outline, it's spelled out more specifically what's going to be covered in this particular unit. Now, the example on the screen, again, is taken from the unit on programming. And so in this case, you're going to see things listed such as documenting programs, working with object blocks, working with Boolean mathematics, loops, branching, data, and so on. After this, we enter the section where each of the specific standards to be met by each particular project unit is spelled out. which of course provides the educational justification for whatever the project is that we're going to be doing. Now, we often get asked if our curriculum-based programs meet the standards for a particular state or district. And of course, while we would love to be able to say that they do, with 50 states and with so many different districts and schools approaching things a little bit differently from one another, being able to clearly align to all these individual standards, of course, isn't really practical or feasible. So instead, what we've done is we've selected the most universally accepted standards that are currently in place in the United States today. And this is going to include, again, the college and career readiness math standards, which are followed by the reading standards for literacy in history and social studies, as well as the writing standards for literacy in history, social studies, science, and technical subjects. Next up, we get into science standards, beginning with the NSES content standards for K to 12, the standards for technological literacy. This is followed by the ISTE Technology Foundation standards for students. Next up is the assessment section, and this includes links to both general course rubrics as well as rubrics related to the specific theme unit. Following this, we have what's called the essential question, and this can be thought of as the major idea that's going to be explored in the unit ahead. Now, in this particular example, which happens to be taken from the unit focusing on sensing and vision systems, the essential question being put forth is, how do automated devices sense and work in the world around them, operate in the world around them? Next up, after the essential question, is the student scenario for each unit. And this gives the students an opportunity to explore the particular unit's essential question. And it's done in the form of a real world problem that students are given to solve. And it's essentially an answer to, where will I ever use this? So in this particular example shown on the screen right now, students are told they're part of a technical sales team working for an alarm company. And just to quote from this particular scenario, in case you can't read it on the screen, quote, "Your company has been trying to increase sales to the museum alarm manufacturers. The decision has been made that sales could increase if there was a web page created that had a section for each sensor, a description of how it works, and a sample alarm circuit that others could use to base designs from. You will have to build a prototype of the situation your alarm will monitor and list conditions that it will monitor. A section on suggested calibration is also necessary. Your team has been charged with this project. Your team will brainstorm what the web page should contain and how it should be laid out. Your team will conduct internet research to discover how sensors work, what other companies do to create data sheets, and how to create simple web pages using Microsoft Office. Once the research is done and the enabling activities are completed, the team will design the sections for the web page. Any software created for the web pages should be documented completely so that another team can easily figure out the work that you have done. All work should be documented in the engineering notebook. Students will devise alarm circuits utilizing at least 3 methods. Each sensor will have a page in the manual, and the sample alarm circuit should explain how each sensor works and sees things the others do not. Students will present their online files along with a presentation of their prototype in hopes of landing a sales contract," end quote. So you can see right here, there are different levels that the students are building a prototype and also breaking down everything, as in learning about circuits, how they have to make something that can be easily replicated. They have to design this web page. So there's a lot of different levels to this. Taking another scenario, which is put forth in the programming theme unit, in that particular case, the student groups will be tasked with designing and building an elevator that's going to need to function in a particular manner. For one example is, if the elevator was stopped on the middle floor and you happen to have the case where someone is pushing a call button on an upper floor and a lower floor at the same time, you basically have to create a protocol for how does that elevator that's stuck in the middle, how does it proceed in that case? What floor does it go to first, or what have you? But basically, creating a protocol for that. So these are the kind of things that are addressed here. And again, the fictional client's requirements are always going to be clearly spelled out, and the students are always going to be required to create a program to address these specific needs. They're going to have to create a physical prototype using the Fischertechnik components, And again, they have to prepare a presentation for these clients that includes a demonstration of any prototype and programming in action, which they're going to do that presentation at the end of the unit. First, though, we have the daily plan, and this is what clearly spells out the expectations as students work through the project in the student scenario, the project we just discussed. Each day of the daily plan can be seen as acting as a guideline, a roadmap of sorts, to spell out specifically what the students are going to look at today and what everyone's going to need to accomplish. Now you'll see that as different concepts are addressed, students are provided with helpful links in the curriculum to give them more information. For example, they're going to have links showing them what's going to be required in that design brief that I mentioned a few times, or the engineering journal. And once again, each day has a different task that needs to be addressed, a different activity that needs to be performed, or a different question that needs to be answered. In the example now on your screen, again taken from the unit on programming, if you look closely, you can see on day 7 there is a discussion topic, which is, how does my dishwasher know when the dishes are clean? Which, of course, your dishwasher doesn't know when the dishes are clean, but instead it's programmed a certain way to go through certain cycles for a specific period of time. So this is an opportunity where the teacher can lead a discussion where this idea can be explored. Now, other things covered in this unit, for example, include things like how data is taken from a sensor and recorded, or how files can be taken from the RoboPro software format and put into an Excel format to be worked on, and then put back into the RoboPro format, and other things like this. Now, as students work through the daily plan and on their answers to each student scenario, they're going to be required to perform research. Again, they're going to do trial and error experimentation, and they have to document the entire process. And again, this means maintaining a digital design notebook and an engineering journal. And again, they're going to have to design and build a working prototype using Fischertechnik, and also create and deliver a presentation of this prototype in action. The curriculum is designed so that each day in the project theme builds on the day before it, and each activity is subsequently more complex, and along the way will provide the information that students are going to need to draw on to successfully complete the projects. And what this all does is it helps to reinforce the concepts for students, and it ties everything together in a really organic and meaningful manner. Now, there's also a section at the end of each unit where various additional materials are collected. And this can include things like vocabulary words, can include links to carefully vetted web-based resources, could be Word documents, PDF files, or even PowerPoints. Once again, each of the 4 project theme units follows the same structure as we've just seen, including the standards, the rubrics, the daily plan, the resource materials, the links, and so on. And as I touched upon before, there are also numerous links throughout the curriculum for more information on specific topics as they arise. And these were all collected in one section at the end of the robotics competition set curriculum. And this will include activity links for things like sketching, schematic drawings, Ohm's law and power, an introduction to working with the RoboPro programming software and becoming familiar with the TXT controller, working with flowcharts, open loop and closed loop programming, working with digital branching, logic levels and programs and triggering, logic gates, combinational logic, analog branching, variables, data, sensors such as the digital switch and the digital phototransistor, as well as the digital trail follower. Next, moving on to analog sensors such as the NTC resistor, the Photocell LDR, the color sensor, and the ultrasonic distance sensor. An introduction to using the camera attachment, using the camera to detect motion, working with color detection, using the swiveling camera as a ball finder, working with the line tool, learning how encoder motors allow for precise control of movements, and building the control panel. And again, as documenting the entire process is a major focus for the curriculum. There's also another section included at the end of the curriculum that spells out the proper procedures for record keeping of the sort. And this is designed to help students to develop proper work habits and embeds technical literacy into each of the projects. This will include things like the requirements for maintaining a digital engineering notebook. These are all detailed here. The elements that make up a design process are outlined. Examples of design documentation are discussed. The problem statement is explained, including its components, the vision statement, the issue statement, and the method statement. Points to be summarized in a design brief are discussed. The elements of testing protocol are outlined. And finally, the required components for an engineering report are also clearly outlined. This is followed by a section collecting the step-by-step assembly instructions for each of the 20 models, which, as I mentioned before, are also included in a printed version inside the set. So all 20 of those models that I flipped through the slides of earlier, this is the part that shows you how to build all those. And again, there are printed materials in the set inside of each box, which will also cover this. And that is essentially everything you get and everything you can explore with the Fischertechnik Robotics Competition Set. So just to summarize, the Fischertechnik Robotics Competition Set contains everything you need. It contains all of the parts, contains the RoboPro graphic programming software, the compact and powerful Robotics TXT controller, the rechargeable AccuSet battery pack and charging unit, all of the step-by-step assembly instructions for building 20 different instructional models, and complete and highly detailed day-by-day curriculum. And I have to mention, the curriculum included in each set is yours to use this year, next year, and for many years to come. There are no additional fees or subscription charges associated with that. That comes with the purchase of the set. Everything you need is included. Each set is designed again for use by teams of 2 to up to 4 students at a time, so it's easily scalable. By that I mean, for example, if you have a classroom of 20 students, you could use as many as 10 sets or as few as 5 sets, depending, of course, upon your budget and how quickly you want students to move through material. Obviously, if you have more students working per set, you're going to move through the material and the projects a little bit quicker than if you only have 2 students doing the building, the programming, the research, what have you. So it depends how big you want to make your groups. And again, all of this is reusable. Students can build a model, they perform the experiments, then they can take the model apart and build a totally different model. But of course, if you ever didn't want to add parts to the sets, or if some part did get lost, or on the offhand chance something got broken, you can purchase each piece individually in whatever quantity you choose directly from our website. Again, the Fischertechnik Robotic Competition Set is designed to make it easy for educators from any background. So it doesn't matter if science and technology are not your main strong point. Whatever it is, this has been designed to basically pack your parachute, so to speak, provide the material you're going to need so that you can offer a hands-on project-based learning experience to your students. And again, project-based is what experts agree is one of the most effective methods known for teaching STEM concepts like robotics. And of course, the golden question, pricing. Pricing starts at just $699 per set. And of course, quantity pricing for classrooms is available upon request. So if you did want to quote for your classroom, please contact us. We'll be happy to put that together for you, and we'll see if we can do a little better on that pricing for you. So on that note, if you have any questions, even though the slide says speak in real time, I normally don't open up the phone lines because we get a lot of feedback and what have you, depending on how people are accessing. So I would ask that if you do have any questions, you can use one of 2 windows, both of which should be on the Zoom toolbar. You could either use the chat window that is listed over there, or you can use the question and answer window, either one which should be available there. So just, type in your questions you might have. If not, and whether you're not sure right now, if you don't have a question right now, or if you're shy or what have you, you could also email me any questions you have. As you see, my email address is right up there. It's Lance, Lancez, at Studica, Studica.com. So feel free to type that in if you have any questions whatsoever about this set, about anything Fischertechnik related. Feel free to just email me directly. So as I don't see anything coming up, I'd like to take this opportunity to thank you for attending today. So if you'd like to get more information, if you'd like to request a quote on this or any other Fischertechnik products or any of the other great products we offer, or if you'd like to speak with your dedicated educational representative for your state, you can just give us a call. If you're in the US, you can call us at 888-561-7521. If you're located in Canada, you can call us at 800-561-7520, both, of course, toll-free numbers. You can also visit our webpage, as is listed on the screen there, www.studica.com/Fischertechnik-education. Or you can just use the little, you can just pick the brand at the top of the page. There's a little pull down menu that'll show the little Fischertechnik symbol like you see there. And you can just select that and it'll take you right to the Fischertechnik pages. Or of course, if you have any questions, want to quote, whatever, and if you like, you can email either the general email address, info@studica.com, or you can email me directly, lancez@studica.com, LANCEZ@studica.com. And that's all, folks. Again, thank you very much for attending. I look forward to hearing from you soon. Take care and have a great afternoon.